Hello everyone, my name is Zhang. I'm a member of the Brinson Lab here at Duke's Pratt School of Engineering. My research is at the intersection of AI and metamaterials. So what are metamaterials? Well, normally with materials you play around with the chemistry to get new properties. But with metamaterials, you play around with the chemistry and the geometry. And that geometry gives the metamaterial additional properties that a solid chunk of the material would not have. And usually with these geometries, you're designing something that by waves reflecting and refracting off of those internal surfaces of the geometry, you get a useful wave manipulation out of it. And that useful wave manipulation is characterized by what we call the dispersion characteristics of that metamaterial. So in our research, we generate data sets by randomly generating metamaterial geometries and then computing their dispersion characteristics. With these two pieces of information and many samples, we then train AI models to act as surrogates for physics solvers. So normally for a metamaterial, if you wanted to compute its dispersion characteristics, that's how it would manipulate waves, acoustic waves, optical waves, etc., that move through it, you would have to use expensive physics solvers that have an exponential scaling in complexity based on the resolution of your metamaterial. But with AI models, you can shortcut that and get a lot of nice generalizations out of it if you train that model properly. So that's one type of research we do at the lab. Another type of research we do at the lab is sort of the opposite direction, where we start off with desired properties, desired dispersion characteristics of that metamaterial. And what we're trying to do is train an AI to take those properties and spit out a geometry design based off of those desired properties. And here at the lab, what we really want to get is model architectures that are really good at understanding physics and can generalize past their training set, like a physics student or a physics expert might be able to do. And in that way, we do architecture search to train better and better AIs to understand physics more and more deeply.